Hi, thank you so much for having me. Thank you everybody for attending. Today I will be presenting Whip Your Data Store into Shape, Redux Best Practices Applied to Apollo Client in Memory Cache. My name is Jenny. I'm a Vice President at the Engineering Division. I work on the consumer business for Marcus by Goldman Sachs. I'm also a member of the New York City chapter of Women Who Code. What is Marcus? Marcus is the digital consumer bank that launched about 4 years ago, and it offers savings accounts, personal loans, soon checking accounts, and credit cards as part of its larger consumer business. When I joined, it was about 50 engineers in one office, and since then we've expanded to about 600 full-time engineers across 4 countries, and we're hiring in several target locations. So we have produced many products and features in short time periods. For example, COVID-19 for the customer assistance program, it took just 72 hours from the time that we realized we needed this feature to its actual launch. And we're able to do this because of our agile technology model, our adherence to good software practices, as well as our modern frameworks. On our website, we used React and Redux initially, and we're currently using React and Apollo. Both are great frameworks, and they both use a data store. As part of this presentation, what you will learn is what is a data store, why your data store structure matters, and what are common pitfalls and best practices when structuring your data store. So you might be wondering, what data do we work with on the UI, and why do we need to manage it? We get a lot of data on our website and from many different places. So one place might be a URL or a query string. Another place might be a third-party script that, for example, an A/B testing library that will tell us whether to render component A or component B. We also might have author defaults that come in that are predetermined, user input, API data, browser data such as cookies, local storage, or session storage, and then other data related to like application state such as flags, or if you think of page composition, data that gets passed down from a parent page down to its subcomponents. And so to keep track and manage all this data, we use a data store. A data store, for the purposes of this talk, is a designated area for storing and retrieving data. And much like a traditional database, it serves as the single source of truth for our website or our application. Many modern frameworks come with a data store, and they work really well with React. React is the front-end library that controls the rendering of a component, and that component can optionally subscribe to a data store so that it can automatically re-render when the data changes. Redux is a predictable single unidirectional data store that offers action creators and reducers for being able to update that data store. And for server-side rendering, we use Apollo Server, which comes with Apollo Client, an in-memory cache that manages and stores local and remote data, which can be accessed with queries and mutations. The big takeaway is that both provide interfaces for interacting with their data store, which means that you have control over the way that you structure your data store. The structure of your data store matters because it's important for debugging that you have a good store so that it can work well with highly interactive components and pages. You also want to make sure that you're meeting legal requirements, reducing reputational risk, and just have a good user experience by reducing the number of bugs and making sure that you're always showing the correct data. So our first case study is loan sliders. So when a customer first lands on the website, they're able to apply for a loan, and they can, as part of their application, choose their target loan amount and monthly payment amount. So when the user first lands on this page, we'll have some author defaults that we load. The user will interact with it, and we'll set cookies so that if the user were to refresh the page, those slider values would persist. And finally, when the user submits it, make a call to the API. The API will return back a set of loan options for the user. And they'll also return a new range for the loan amount and the monthly payment amount, which we show on the left-hand rail, which we call the backpack. And so the user can continue to interact with those sliders, and we'll either filter the data that's being seen on the right-hand side, or we'll make another API call and get back new loan offers for that user on this page. So when you're structuring your data store, it might be very tempting to sort of look at your data that you need on the page visually and structure your store after your page where you say, I need to show the monthly payment on the left-hand rail, and I also needed to show it on the page. So I'm going to store it in both places. And that can lead to a lot of bugs because sometimes the two components can fall out of sync. Or you might be showing the wrong value. You might be showing like a cookie value instead of the latest user input. And if I were to ask you, why we're showing one over the other, debugging is very difficult because you have to step through each call made to the data store and see what update showed the wrong value. So what happens is you're really coupling the business logic of what will take precedence, which will make it harder if you ever change that business logic in the future. So you can sort of think of it as if you were to design an application and you're getting a user's like credit score on the back end. So if you were to get a credit score from TransUnion and Equifax, right, you wouldn't do a computation, pick the higher one and store it in your database. You'd want to store each one so that you know which value came from which provider. And when you're doing your computation, if you change it, that business logic is decoupled from your database and you're not storing any computations in your database. So best practices to fix this issue on the front end are very similar. You want to make sure that your data store is following any best practices that you would follow in a database. So you want to make sure not to duplicate any data. You want to avoid modeling your state after your view or your APIs. And you want to make sure you know where your data is coming from by using semantic names, and also by making sure you don't store any generic computations into your data store. In Apollo, you still want to continue to follow the best practices. So Apollo is interesting because a lot of the management or caching of your requests is automatically done for you, but you can explicitly interact with the cache and create and set your own values with the @client directive. And so because you still have control over setting it, you want to make sure you keep following the best practices when you're interacting with that local cache. And you also want to make sure you understand where your data is coming from, because it's a bit more complex now that you have server-side rendering. And you want to make sure that you know whether or not you're pulling your data from your cache or you're pulling your data from your network. And you need to make sure it matches with your business logic that's required. Our second case study is a document library. So when a user calls in to a customer service representative, the customer service representative can look up the user and they can pull up any documents associated with that particular user. So on the left-hand side, we have a document list, which will pull all the documents. The customer representative will select one of those documents, and then it'll be rendered in the document viewer. If you were to load the documents for a particular customer and there's no documents, the document viewer would show, like, sorry, there's no documents for this person. And so when we originally designed this page and this component, the desire was for each section to work independently. So the document list was really responsible for all the whole list of documents. And then the document viewer was responsible for its own particular document. However, when we built it, we had issues where we would flicker and show the wrong status. So for example, when you first loaded the page, the document store would be empty. So we would show that there's no documents for this customer. quickly thereafter, we make a call for the documents and show loading. When we get back the documents and the customer service agent selects one of the documents, we will set that document ID, but to the UI, we show an error because there's no blob or data for that document that's there to be rendered. And then finally, we go and we fetch the data for that document and we show the correct document on the screen to the agent. And you can think of the problem for this situation as being twofold. You can think of one issue being that there is insufficient knowledge of status updates for the data. So the document viewer needs to know if the document information that it needs has been fetched or is in the process of being fetched, and there was a disconnect in the components there. The other problem you can think of it is that the components were designed to be independent, but they're really not. They're both manipulating or reading different parts of the store. So both the document list and the document viewer need to see the full list of documents or the length of documents in order to render the right message. And they need to interact with the document section of the data store in order to set the document and the document information that's related to it. So how do we solve this? So there's a few different ways that you can solve this problem. The first is you can transfer all that data management to a common parent. So even though these components were designed to be independent and make their own queries, since they're not, the parent can do so for them and then just pass down the information once it's ready to be rendered. The second option is you can work with your designers, and so you can change your design so that it doesn't have the same requirements and the components can interact more independently as they were sort of meant to be. And finally, you can store the status information of whether or not this is like the initial load or whether or not the call is in flight, successful, or if it was a failure when it responded. So you can store that information in your store, and then each component will know the current state, and you can solve for the issues where you're showing like intermediary incorrect values on the screen. When you're using Apollo by default already provides the loading state on all of the queries. And because you're doing server-side rendering, you can also prefetch and aggregate a lot of the API responses server-side, which is gonna result in less lifecycle updates. So there's gonna be less situations where you're showing the wrong state. The other thing is that with Apollo, because you have a cache, the components can interact a little bit more independently, because if you have the same call from two different components, one of them will pull it from cache because it'll have the same arguments passed. So it'll match and pull from cache. So you don't have to worry as much about making sure that the component domain is independent to optimize those calls. And regardless of what data store you choose, you want to make sure that you follow the best practices where you regard your application state as an in-memory database. So that means you want to make sure you don't model your data store after your view or your APIs, and you don't store any computations. Make sure you know where your data is coming from and use semantic names. And make sure you communicate data stages so that your components know whether or not the data that they require is in the process of being fetched or has been fetched. If you'd like to know more, contact me. My information is on the screen, as well as Women Who Code for the New York chapter, and Goldman Sachs Careers if you're interested in joining the team. And for those of you on the chat, I posed the question, why did the data store get robbed? The answer is it left its cache in the window. And so I'm happy to take any questions.
Hi, thank you for your talk.
Thank you.
I have a couple of questions. So I'm trying to level up in my use of GraphQL Apollo. So I guess two things. One was I'm not as familiar with Redux. So early on you talked about how that was unidirectional, and I just would love if you could explain what that means. And I guess I would also be interested in a little more detail around like, or maybe an example of like the prefetching for Apollo.
Sure. So for Redux, actually, one of the first technologies I started using when React came out was Flux, which is the concept of many data stores. So your components would register to the data store, which then handled the calls to the APIs that was closest to its domain. So you can think of if you're creating like a website that has like comments and replies, right? You might have one section that handles the comments and one section that handles the replies. And as a second version that came out of that was Redux, which was known because it was one store. For some applications, I think it became difficult to talk with those multiple data stores because you'd have to like listen to multiple data stores or make like a join data store to solve certain edge cases where maybe somebody replied to a comment, and so it's also it's like a join table where it's related to two different things. And so I think in practice with having multiple data stores for some applications, that became a little bit complicated where you had strange bugs come about. And so React came out with one single data store to sort of simplify that, where everything registered to that one data store. And then you would break up your logic within the data store. The second piece to that is in React, you have application state. So you can trigger a change on a component by calling like this.setState. And so those state changes are asynchronous, which means it's sometimes difficult to make sure that one thing happens after the other. So the difference is when you trigger a change through Redux and you use these like action creators, they go through this whole cycle where they get registered to dispatcher, and then they go through and it updates the store and the component will update. So because it goes through this whole flow, it guarantees that it will be consistent. And every time you run it, you're gonna get the same result. It's not gonna be the same kind of asynchronous call that you get with setting state. So you get a lot more predictability in your updates to your components. So that's the first question.
And can I jump in and just ask a follow-up then on the state thing? So I guess I just wonder, would you manage all of your React components state through the data store, or would you do any like set state at all?
We still use SetState a lot in SetState a lot in practice. I think it depends on the application of the component, because if you have something that's very specific to the way we kind of would think about it when designing a component is if you have a change or an update that's very specific to that particular component, then and nothing else really cares about it, then we usually use SetState. But if you have something that many components are listening to, or you want to make sure is consistent, right? Like if you have many bugs because you're updating two different things at the same time, you want to use Redux to make sure that they update across both the components and they update in the same order. So I think if you have a lot of complicated logic where you SetState has a callback, so you can do something after the state executes for that reason. So I think if you have a lot of complicated logic where you're calling this dot SetState and then trying to do something else after that state updates, it's better to use Redux, and then you'll just use like React's lifecycle hooks that come in a component of did mount, did update, and yeah, that's the original like React stateful component. They have lifecycle hooks.
Right. Yeah.
That'll.
Thank you. Sorry, I don't have my video. You can't see me nodding, but thank you.
You're welcome. And what was the second question?
Great question. Oh, the prefetching. I've just never prefetched a query before, so I guess I was kind of wondering how that, if you had maybe like an example of when you would use that.
Sure. So, so on a component, we might have maybe like the document list, right? We have many components, and we might have a section where we're searching for a customer. Maybe we have a sidebar that shows some customer information, right? Both of these need like customer ID on a page, so we need to go and fetch the customer ID from the backend. So you don't want to do that more than once. So what we do is on page load, there are certain React hooks that get called, like the constructor, if you're doing server-side rendering, is server-side, and then your other hooks can be on the client side. So on that initial page load, you can aggregate all the calls. You can register them. Like what we do is we register them into an array or an object, and then we take them all together and we make one call server-side to get back all those responses, and then just provide them back to the components. So it's using the React lifecycles a little bit, or I guess the constructor, in that we're doing server-side rendering, and then we're registering those calls ahead of time so that we explicitly call them out so that they have to be prefetched on page load. I don't know if that answered your question.
It definitely gave some context. Thank you.
Are there any other questions from the chat?
I had a quick question. I have never done server-side rendering before. So for your projects, when you do server-side rendering, are you using React for that or some other technology?
We're using React and Apollo. So Apollo is twofold, and it comes with Apollo server and Apollo client. So we use Apollo for all of our server-side rendering and our calls.
And for the front end, you are using React with Apollo too?
Yeah.
Okay, thank you.
What are some of the differences between, I guess, like using Redux versus Apollo client?
So some of the differences, I think, are with Redux, you have a lot more control. I think for me, when I'm working with Redux, I look at the data store and I write my call and it all updates the data store. I think with Apollo client, because it does, it handles a lot of the remote and the local calls for you. It's really just making what they call a query or mutation, which is just like a get or a post, right, to your server, checking if it's loading and rendering. And I've also really liked the fact that it's that the use of the cache is interesting. It's like, you have to think about it sometimes when you're building the components to make sure you're pulling from the right place. But it works really well with React and with React stateless components, which are very popular right now. And so you can use like React hooks and stateless components to work with Apollo. They work really well together. I see another question in the chat, which is, what does unidirectional mean?
That was me, but I asked it to you after the talk also.
Oh, great. Yeah, unidirectional is just that flow to the dispatcher and then back down to the components. It's not just part of Redux, it's also part of Flex and some of the other architectures where you, if you think of like some other front-end frameworks, they have like two-way data binding, where one change on a component will change something back-end, which will change something back on the component, whereas React is usually used with libraries like Redux and Flex, which are considered unidirectional, where the change goes one way. Like there's no back and forth updates. Are there any other questions?
Well, thank you very much for speaking today. I think we learned a lot about data stores and some common best practices. And thank you everyone for attending.
Thank you so much.
Thank you.
Thank
Bye.
you.